This is chapter four, conceptualization and measurement. In research studies, we look at how are we going to frame our study and what tools are we going to use to measure the data that we're looking for. So conceptualization is the process of defining terms in words. What are we looking at specifically? While each of us have our own ideas about what concepts mean, we might not have the same idea in mind when we hear those terms. Lots of times when we use acronyms or shorten things up, we may not know what those are. So in conceptualization, we define our terms in words, what we're looking to do. And when we're looking at measurements, we're looking at the different types of measurements that we're going to do. We have both inductive and deductive research. Deductive is in deductive research, conceptualization helps us translate portions of an abstract theory into testable hypotheses involving specific variables. What are we looking at? How are we going to measure that? What are we looking to test? What questions out there, and what do we believe may happen? Inductive research, conceptualization is just as important, and it's a part of the process used to make sense of related observations. What do we see? How do we interpret the data, or how do others interpret experiences? And we record those. So let's go into a little bit more depth on what a concept is. Concepts provide us with a mental image that really summarizes a set of similar ideas. If we talk about a framework, we have a concept of what's happening. We may not know these specifics to it, but we need some idea. And these are, like I said, a set of observations or feelings or ideas. We require explicit definition in research because concepts require an explicit definition before they are used in research because we cannot be certain that all the readers of our papers or our findings will share that same definition. So we need to be very clear at the very beginning of what we say and what we're doing. So we have to have special clarity and what it means to when we use them, and we must expect others to do the same. So we need to understand and be on the same sheet of music. I got this slide because it breaks down concepts into different definitions of it. But I like that through concepts we can build a mental map of reality and develop our critical thinking. Concepts are fundamental in learning and knowledge construction because we are looking at how things operate, be it from our observation, uh, our feelings or ideas. We look at what these all mean. Okay. So let's look at some of the other things. Conceptions in conceptualization of practice, defining a youth gang. Youth gangs conceptually are difficult. Defining in terms of youth gang is difficult because youth games are not particularly cohesive. They vary from one area to another with members and whatnot. Individual gangs change their focus over time. Many have a hodgepodge of features with diverse members and unclear rules to us. They may have very clear rules to them, but we won't necessarily understand it. Um, when we look at it from there are many incorrect but popular myths about gangs. Well, come back here. I moved my cursor too far. Boop. Um, where was I? Oh, a hodgepodge of features like from a location or dress, or if you want to use like the 1% motorcycles, different rules that go on. There are many incorrect, but or I should say, distinguishing from other groups. Youth gangs are only one type of social group, and it's important to define youth gangs in a way that distinguishes them from these other types of groups, which, as childhood play groups, youth subculture groups, delinquent groups, or adult criminal organizations. We look at, primarily age, but we do that as far as, the youth gangs and where we're going from. Um, Unidimensional and multidimensional concepts. While defining a concept, one needs to consider whether the concept is unidimensional or multidimensional. Unidimensional concepts require specifying and relating concepts that belong under umbrella of a larger concept, where uni is singular in function and in form. So when we look at gangs, we really have to look at what specifically are we looking at? All male gangs, all female gangs? Are they interrelated? Where are they uh, based on age? Are we looking at um, location, geographical? All these types of things we have to look at. So we need to identify the variables that go on. Um, Variables identify and meaning concepts. After defining a concept in theory, we can identify variables corresponding to the concepts and develop process or procedures to measure them. A variable is a characteristics or property that can vary. When we look at a variable, we're looking at things that could go that aren't necessarily um, across the board. So if we look at youth gangs in greater urban areas versus rural areas? Are we looking at the membership of the groups? Do we look at what the intent of the group is? So those are different variables in which we do. So when we look at the conceptualization of social control, it's on the basis of defining and determine variables that represent the conceptualization of social control. It is defined as all the processes by which defined and respond to deviant behavior. So we're looking at what those specific is. When we're looking at the concept of youth gangs, we're looking at the deviant behavior of what a gang kind of does. Not just a group of kids who are hanging out, but a gang who is formalized and are looking at a more organized um, social structure and what they're meant to do. How will you know when you find it? An interesting one because it builds itself on different things, mainly on operations. And this is achieving a measurement or a measurable validity, a procedure for identifying and indicating the value of cases on variables. Then we move into what they call operationalism, which is the value of the variable. This process of specifying the operations that will indicate the value of a variable for each case, because each case can differ. So we need to have a variable, and then we get more specific, more narrowed in on those things. And then we have the indicator, which is the another value of the variable. It's the question or other operation used to indicate the value of cases on the variable. Whatever, this all presents confusion. Social researchers have many options for operationalization of for their concepts. Good conceptualization and application can prevent confusion later in the research process. That's why when we do it in the very beginning, it is so important to define our terms and the concepts and theories that we are trying to do very succinctly, very um, directly. We don't want to get into a lot of fluff about it. We are looking at specific actions and trying to determine reactions or correlation between actions. So these types of things, are important to us as researchers to define right away. So where are we going to get this stuff, right? Government reports are usually a good place because they provide a lot of statistics. Government reports are rich with accessible sources of criminal justice data, the UCR from the FBI. all, well, I should say, not all, the vast majority of law enforcement agencies contribute to the UCR and they send in their data. You can contact individual departments or agencies and they keep their own records. But government sticks are usually generally through a central agency and usually are of pretty high quality. They are generally accepted as true stats, true data, and but they should be used with caution only because they are not 100%. Usually the things that you can guarantee on are the things that you do. Um, because government stats, with any kind of stats, you can put them in different categories and they can, if you extrapolate them out, they can say different things. So you really want to be understanding of them. Now, you can get data from nonprofits groups and prior university researches and private businesses. And again, they all, for the most part, will probably be good data. But you still have to be kind of not skeptical, but just aware that it can be different. You can unless you are directly involved in the data collection, you have to at least acknowledge that there can be errors in the data. Okay. And like I said, local police departments, they provide stats on arrest. Could be from anything from sale or possession to drunk driving, liquor violations. They have all of the stuff, all the data, and they may or may not turn it into the feds. But they're usually a pretty good idea. So when we're looking at where are we going to look at data, we can look at from government reports from the different entities here, both local, federal, whatever. Um, but regardless, if we have all this data, it inevitably leads to one thing, and that is what questions are we going to ask? How are we going to um, have the data support our questions, or if we're doing interviewing of others, how do we, or I should say more importantly, how do we elicit a more substantive response? And when we construct questions, we look there's different types. Um, if we're doing, say, a survey or something like that, that's more of what they classify as a closed-ended or fixed choice question. It provides pre-formatted responses for the respondent to circle or check. The responses, the response choices should be mutually exclusive and exhaustive so that every respondent can find one and only one choice that applies to him or her. There are some advantages to it. Respondents are more likely to answer questions that the researcher really wants them to answer. It's right there. It's real quick. And indicating response choices reduces ambiguity. I can never say that word. As far as what we're looking. The typical kind of question that this kind of runs into is your Likert. Do you, on a scale of 1 to 5, how do you feel X, right? And you put in there, and it usually is one question or one answer. People sometimes delve way too far in it. One thing that I like to do if I'm conducting a closed-ended question or a fixed choice, I just say, when you read that question, what is the first thing that comes to mind? A first answer. Don't delve into it. Well, in this situation, it's this way. In this situation, it's that. No, just as soon as you read it, what is your gut reaction of A, B, C, D, or E? Okay. Now, to the opposite of it, there are open-ended questions that do not have an explicit response choice. These usually are survey questions without a predetermined response choice. It is preferable with the range of responses that cannot adequately be anticipated. There's more context to a yes, no, maybe, somewhere in between. The advantage of these types of open-ended questions lessen confusion about the meaning of responsive involving concept or complex concepts. If if I wanted to know how blue is the sky, you can put it on there, different colors, and you can have them 1 through 5 on the different shades. But if I put on there, what is the meaning of life? I can elicit a more complex answer because it's a more complex question. So they do have their place, and it's usually in surveys. I like doing those surveys because there are always, even in my personal opinion, and it's probably, and I have to call out my biases. I do that. In my personal opinion slash bias, there are usually more going into it than a yes, no, one, two, three, or four type of question. Now, unless that question is written in such a way that it's very clear, there's really not a lot of ambiguity of where to go with it, then it's okay. I like open-ended questions because then it gives context to what the person who's answering it is giving. So, after we have our questions, we have to start making our observations. So when we look at observations, we're looking at a methodology used to measure characteristics of individuals or events or places. These observations may be the primary form of measurement in a study, or they may be supplement measures obtained through questioning. When I did the last ones I've done were pretty much, I really didn't do observational type things. I looked at the participants' observations. What did they think of a particular thing? And I like that because in a world of ever-changing criteria or material that fits more with in line with the more a more diverse audience, we look at personal observations and trying to get as many as we can so we can tweak whatever we're doing to do so. Um, yeah. The other part of this is the systematic social observation, SSO, and it's a strategy that increases the reliability of observational data by using explicit rules that standardize coding practices across observers. So when we're looking at it, you are only to look at, well, let's go back to the Stanford. You're only looking at the inmates or you're looking at the guards. You're looking specifically at the levels of physical contact versus verbal or emotional, those types of things are very specific things that we're looking at so we don't get kind of sidetracked to something else. Um, then we have collecting unobstructive measures. Observations, or I should say, get back to this. Unobstructed measures are based on physical traces or other data that's collected without the knowledge or participation of individuals or groups that generated the data. So when that Stanford study happened, they had those observational two-way mirrors that the participants couldn't see. So they didn't know what was going on. And it's nice in that sense because um, you're not influencing the participants' actions. Okay. But it does come into four types of measurements. There are the physical trace elements, which are past behaviors that one type of unobstructive measure that is the most useful when the behavior of the interests cannot directly be observed and they cannot be recorded in a source of available data. There are archives, which is measures that can also be created from data that is available with diverse forms of media, such as newspaper archives or magazine articles or radio and talk shows. With social media and the electronic age, they say once something's on the net, it never dies, right? It never goes away. You could use it for journals and emails. It's always out there in the ether. So it's archived somewhere. It's just where are you going to get it? Then you have the simple observations, which is just what you personally are observing. Contrived observations. Subjects are studied in real life circumstances and environments. They may or may not know that they are being observed. In contrived observations, subjects are studied in controlled settings like research labs, or something like that, and they know that they are being observed. But after a while, that becomes secondary. Sometimes you have, um, depending on what they believe it is, different types of behaviors. Um, so this is what I mean. If it's in a lab, and like I believe it was in chapter 3, one of the slides showed a child at play at a small table with blocks. And then you saw the researcher in the adjoining room, um, looking in on the observation. Now, the child could be told, there's someone behind the mirror and they're just watching and looking at what you're doing. Don't pay them any attention. They won't interact with you at all. You just do, what you want to do with the blocks or whatever. And they'll come get you in 15 minutes, right? That's knowing that's there. When you go into the more, mm, outside area, there becomes more variables of them interacting with people who are not part of the study. So that's why they like to use a controlled environment. Whatever, the only physical trace evidence in archives is, no, I don't have to worry about that. The only thing that you really got to remember is when looking at the different types of unobstructed measures, we really got to look at the different types of things that we could use that are the least not least detrimental to our subjects, whatever those could be. And because when they're not in any kind of duress or distress, you usually get better data. Okay? So, let's go with our measurement techniques. Interrelated measurement tools. Using available data, asking questions, making observations, and using the unobstructive indicators are interrelated measurement tools, each of which may include or be supplemented by others. There's something called triangulation. Now, when I first heard of triangulation, I was looking at it from where do I think I am on a map? If I can see a water tower off to the left and a radio tower off the right, and I look at the map, all right, and I can uh, orient the map to so that on the map I'm looking at the same water tower on my left and the same radio tower on my right, and I can measure which way it is. I can accurately triangulate my position. This uses multiple methods to study one research question. Also used to mean the use of two or more different measures of the same variable. So if I wanted to check out something, I could use an observational type thing, use an archives. I can use a more direct type of data gathering by asking those questions and comparing the two. So that helps. I can use even a third or fourth one to really kind of narrow in on my data to see if it's good. What it does is improve confidence and validity. Using triangulation strengthens measurements considerably by improving confidence in the validity of the measure. If if I use one test and it gives me an answer, just call it 10, that might be right and it might not be close enough. But if I use two, three, or four different methodologies or measurement tools, and they all give me 10, then I know that 10 is really the answer. So we have that. Then we have they call divergence concepts. It's the result. If results diverge with different measures, it may indicate that one or more of these measurements are influenced by one or more measurement errors that we can tolerate. Divergence between measurements could also indicate that they are actually operational different concepts. Um, how can I explain this? So if we go back to those measurements, and my measurement said 10, but I use different measurements and I get 10.2, 9.8, and so on. They're they're divergent in nature because the measurements may be looking at something else that's affecting them, but they're still giving me the same or relatively the same answer. So we have to be able to understand what those are and be able to kind of call out when things don't aren't going to plan. Okay, so how do we put this into action? You have a really good case study that kind of goes through defining inmate misconduct. And um, it the case study looks at the safety of a prison or jail or whatever, and the levels of inmate offending behavior or inmate misconduct are the indicator of the safety of the prison or jail. This study was done by, I believe it was Steiner and Woodridge, and they had a survey. They collected survey data from inmates as well as official records for the same inmates. So if I'm looking at inmate 001, I'm talking with that one, and I'm also looking at the correctional staff, and we're saying, okay, on inmate 001, tell me about X. Right? They collected data from two groups of inmates, those who had previously served time before and those who had not, the first timers. The respondents had been given confinement for 6 months or longer, um, because you want it to have kind of getting into a routine. Believe it or not, life in jails and prisons do run on a routine. And if you're too new, you don't know that routine, you don't know the rules, even the unwritten rules by the inmates. So it takes a little bit longer to do that. The inmates were asked whether they had physically assaulted another inmate or other than because they tried to hurt them first. They also official measure of the assault indicated these behaviors as well as attempted assaults. And the results of the study that in the site of self-reported offender behavior was 80% higher than official rates of inmate perpetrated assaults. So they're looking at how these things all come together as far as um, looking at the individuals, looking at the systems. So when you have this um, intercedence of self-reported offender behavior was 80% higher than the official rates. Um, there's a lot more going on that maybe has not been quote unquote reported. You know, it's unfortunate, but the saying is true: snitches get stitches. And you take your assaults or whatever, and that's the life in prison. Regardless, there are different measures that we do in collecting data. And we're going to kind of highlight these here real quick. Levels and measurements is the mathematical precision by which the values of the variable can be expressed. And we have different types here that, like I said, we will go into. The nominal level of measurements, it's the qualitative and it has no mathematical interpretation. While the quantitative level of measurements, the ordinal, the interval, and the ratio, are progressively more precise mathematically. That's the difference between hard data and feelings or impressions. So let's go through them real quick here. Um, oops, come here. So, uh, categorical or qualitative level, the variable's nominal level of measurement have no mathematical interpretation. They vary in kind or quality, but are not in any particular amount. Values are known as attributes. The values of nominal variables are termed as attributes. The attributes of categorical variables do not have a mathematical meaning, but they must be assigned to cases with great care because they have two different things. Mutual exclusive attributes, which is a variable attributes or variables that mutually exclusive, is very, in every case, they have at least one attributes and then they also have exhaustive attributes, which is our variables, attributes, or values in which every case can be classified as having one attribute. It's the attribute I would have used would be, say, attending a particular leadership course. When I was looking at leadership, I look at those types of attributes. But again, this is a qualitative, not a quantitative. So let's go with the quantitative. Um, Absolute distinctions cannot be made in sometimes. Ordinal level of measurements is the measurement of variables by which the numbers indicating the variable's value, specifically the order of the cases, permitting greater than the less than the distinctions. Absolute mathematical distinctions cannot be made between categories. This is I like this one because it talks about um, more of uh, the greater propensity to do something. It's not specific. It kind of goes to like the school grades, right? When you say how people are doing, you have A, B, and C. Well, they're doing really good. They're primarily A's and B's. They're A, B student. Do they have C's? Yes. Are they of a great amount to impact the overall? Probably not, but you still have to recognize them. The next one is the interval data. These represented by fixed measures of units and is a measurement of a variable in which the numbers indicating a variable's value represented to a fixed amount units, but have no absolute or fixed or 0 point. Um, so these, if you look at both the IQ score and the income range, those give like again the propensity. It gives you um, an estimation. It gives you a range primarily. You know, it's not necessarily something that you can put your finger down, but the interview interval is um, has equal parts to each side, like the 40, the 100, and the 60 are all equal, and the data between the 40, 100, and 160 are spread out. You're giving um, specific guide or specific, what's the word I'm looking for? Specific ranges, specific areas, and how many people fall into those each individual ones. Then we have the ratio data. These represents fixed measuring units in an absolute 0 point. By using ratio levels, it measures a variable by which the numbers indicating a variable's value represents fixed measure units, and there's an absolute 0. For most statistical analysis in social science, the interviews and ratio levels of measurements can be treated as equivalent. In interviews and ratios levels, for the most statistical analysis, these interviews and ratios, our measurements can be also done as an equivalent. Oh, when we're looking at ratio data, it goes back to when you took statistics. And this is why a lot of places, even at a master's level, even at a doctorate level, you have to take statistics again and again because these are very um, complex subjects. You can get lost very quickly in them. And depending on how you are utilizing your data, of how you are doing your measurements, and how are you going to present those measurements depends on what kind of data that you're going to use. So the properties of measurements, when we're looking at what we're going to be reporting on, it does give the a little cheat sheet of what things are done, like causation, or if you do A, you get B, is equal to or greater than type of thing. It does help out with um, what ways should you, or what methodology in relation to types of measurements that you should use. So let's move on. It's a very complicated thing, and you wouldn't be the only ones after you read it going, I have no idea what I just read. That's okay. The best thing to do is to look at um, different presentations of what those measurements are. So if you are a little cloudy at a nominal or a ratio or anything like that, just don't take your textbooks. Go out and Google different types of those terms and read those, and then come back and then read your text again and see if it makes sense. A lot of times it's something that we have to look at a couple times to really understand what they're saying, and it's you wouldn't be unusual if you didn't understand it at the first time. The main thing is to keep at it and to not just say, well, I don't understand it, close the book and leave. Do it from, I don't understand this. Let me go out and search for it more. It's one of those things that it's very difficult to explain. You just have to kind of do it type of thing, and then it kind of clicks, if that makes sense. So don't worry about it if it is a little confusing. It always is. The thing is just to keep on going through. Okay. All right. So operations developed to measure concepts should be empirically evaluated for its validity, meaning what kind of things are we looking at so that if someone else, IRB or a peer review comes through it, how are we going to show that the data that we have is is good? It should be evaluated for its reliability. If I throw a ball off of a, 10-story building, I know the ball is a constant. I know that the gravity is a constant. I note if there's a crosswind or any type of wind, and I keep on dropping it in the same conditions, I should have the same amount of time from the release point to when it hits the sidewalk. So it can be tested. I have those numbers out there, and based on those numbers, you would get the same results. Okay. What this does is it helps with what they call the reliability and the validity. How reliable is your data, and how valid is it, right? So when we look at measurements, that what is presumed to be measured, there's a thing called measurement validity. This is the type of validity that is achieved when a measure measures what is presumed to measure. Yeah, I don't like that definition either. That's why I included some of these things, right? Validity is the extent to which the instrument that are used in what your experience measures exactly what you want them to measure. That makes a lot more sense than what your book does. Okay. And then the reliability, the extent to which the outcomes are consistent with the experiment if it's repeated more than once, i.e., dropping the ball from the 10th story. Okay. You have the different types of validity. You have face, content, creation, and construction, or construct, I should say. Face validity is the type of validity that exists when an inspection of the terms used or items used to measure a concept suggests that they are appropriate on their face. If I'm using just a timepiece that is synced from releasing the ball to the plate on the ground that stops it, that's good on its face. Content validity establishes a measure that covers the full range of concepts meanings, meaning how different we couldn't use it for the ball. So in the Stanford, we're looking at what people tended to do. You have different people doing similar things and they had similar outcomes. Uh, Criterion is established when scores obtained in one measurement can accurately be compared to those obtained with more direct or already validated measure of the same phenomena. So if I redid a test or redid an experiment from 10 years ago and I given the same conditions, given the same constructs, I get the same results. Okay. That's the validity. Construct validity is the type of validity that establishes by showing that the measure is related to another measure as specific in a theory. Now, I don't have a theory coming right to mind just yet, but let's see. Let me take a second if I can drum one up real quick. If I do, I'll bring it. I will post it on there. So, with any kind of thing, we're looking at how how reliable is the data? How valid is the data? Because validity, root word is valid. How if it's reliable, it can be done over and over and over again. If it's valid, that means we have nothing that is um, imposing or corrupting the data that we are getting. Okay. Let's move on. All right. I'm kind of reading off of my script. So, reliability consistent scores of a given phenomenon. This one I used target practice, right? Reliability means that the measurement produced yields consistent scores as long as the phenomenon being measured is not changed. If a measurement is reliable, it is affected less by random error and the chance variation. That is unreliable. If it is a prerequisite for a measure of validity. So this is what I mean. So target A, poor validity, good reliability, meaning I'm aiming for the center, but I keep on having a tight uh, window of where the rounds are going. So anytime I do it, it's going off to the side, but I'm aiming for the center. So my is my test valid? Am I hitting the spot where I'm going for? No, it's not. But it's very reliable because every time I run the experiment, even though I'm not hitting the center spot, all the data points to one area. If I look at target B, I have both poor validity and poor reliability because it's all over. It's the shotgun approach, right? Target C, good validity, good reliability. I'm pointing at the center of the target. I'm putting my round down range. I'm hitting the center of the target. I have that area. Okay. Um, they have a thing called test retest reliability, and it's a measure that shows it's a measurement showing that measures of a phenomena of 2 points in time are highly correlated in the phenomenon that is not changed or has changed only as much as the phenomenon itself. Let's put this into action. Let's put this in the real world. Okay, so let's use um, target C. That was my first thing, right? Um, Everything was fine. I go back later and I get the results from target A. what is going on? It's the same pattern, but it's not in there. So what is going on? This is the test retest reliability. If the second set was the same as the first, then we know we're good. It hasn't changed, right? If it has, then we know that there's something that's wrong. All right. When we look at measuring reliability, there's a thing called inter interterm reliability. And it's an approach that calculates reliability based on the correlation among multiple items used to measure a single concept. So kind of goes back to the triangulation. We're looking at different things and it's coming up with different answers. All right. Your text talks about Cohen box alpha, which is a statistic that measures the reliability of items on an index or a scale, kind of a sliding scale or a graph. Um, there's a alternate forms reality, which is produced for testing the reliability of responses to survey questions, in which the subject's answers are compared after the subject has been asked slightly different versions of the same question. And then they look at the difference between them. They do this a lot for like if you ever taken the MPTI, they actually ask you the same questions, but in different ways. They do this in psychological evaluations. They ask you the same questions, but maybe only change a word or two, and then they kind of go through them and see if you have the same answers or how they differ. Okay. This also has what they call split halves reliability, which is achieved when responses to the same questions by two randomly selected halves of a sample are about the same. Meaning, if I ask you something and my research partner does, the answers are the same. Then they go into the intra-observers reliability and inter-reserves reliability. A lot of this stuff I've never used. All right, unless you are going into a lot of um, fixed data, really deep data, and using human subjects and stuff like that, you probably will never have to worry about this type of thing. Okay. But as a whole, you should at least have some frame of reference with this, only because it could come up at some time. Okay. So let's go with the slide. Did we measure what we wanted to measure? That's one of the things that is always key um, when we're looking at validity. Um, it assesses the reliability of a measurement to be established its validity. A reliable measure is not necessarily a valued measure, and the validity measures the judge to be worthwhile on the basis of only a reliability test. Meaning, if we're looking at a set of data points and we look at it and say, I did everything right, but it's still not, it shouldn't be this way. So we need to redo it again to make sure that we are hitting the spots. We're not doing there's not an error in it. Um, we use measures whose reliability and validity have been established. That's what we want. That's what we look at from, okay, they've done it in the past, let's do it this way. The best strategy is to use measures that have been used before and whose reliability and validity have been established on other contexts. If I use a measurement device, I don't want to use something that's new and improved, maybe as like in addition to, but I will always use something that has passed through peer review, that has stand up, that has that validity and the statistical reliability. Um, because if you're using something new, then it comes to, well, how do we know that it's actually measuring what you want to measure? In all these types of things, we're looking at how do we measure or how do we get the data that we want from our subjects or observations or stuff like that? How do we get when we get our data set, how do we know that is the true data? How has it not been corrupted or influenced in one way or another? How are we going to be able to present this material so that when others look at it, they can say, yeah, I believe that this is true. Or if I did the same thing, I would get the same results. I go back to, I believe it was chapter 2, when they talk about the intimate partner in Minneapolis and how they looked at if the parties were facing arrest, there was half as much recidivism. It went from 26% to 13. But when they got that data and they tried to do it again, they found that it wasn't the data wasn't reliable and it wasn't valid because there was other things going on. So when you do your methodology, you want to ensure that you're using good data that's taken from it that can be shown that it will happen every time. And that way it stands up to the reliability and the validity of your study. All right. And that's about chapter 4. These lectures are just about an hour long, and I know some of them are going to get deep, like this one, a little deeper than what the other ones were. Like I said, be sure to really, if you are getting slightly confused, and that is, like I said, totally okay. Don't stop though. Don't just close the book and say, I'm not getting this. Either look for alternate explanations for it. You can contact your instructor. If I'm your instructor, contact me and we'll kind of navigate through it a little bit. And maybe we can frame it in such a way that it just clicks for you, right? Because everybody's different. All right, that's it for what I have today. And I'll be talking to you soon, probably in chapter 5.